So we can start, right? Today we will continue the previous section, I mean Terraform. Uh, Coming to previous section, we already covered how to automate deployment of a EC2 server. Okay, so that's a simple deployment. Coming to another scenario, we can create uh, the network. I mean the VPC, subnet, routable. What are the things we are going? I mean manually doing the same thing we can automate. Okay, the Terraform. Okay, so today our agenda is deploying multiple services. One, we will configure VPC, then internet table, sorry, internet gateway. While creating internet gateway, we need to provide the corresponding VPC, right? So that we will refer in creating internet gateway. Then what are the things? I mean, all of you, how we configure? We already configure VPC, network, all the things, right? What are the components under VPC we need to configure? Create our own VPC and the network. Now I created VPC and internet. Next thing is subnet, right? Subnet. When we're creating subnet, we need to associate that subnet, right? I mean, with a route table. So we need to create route table also. Table. Now subnet and route table there. So next thing we will do what? We need to associate, right? Subnet association. Thing after subnet association, yeah, we will add one route, right? This is our custom route that is for internet access to the internet gateway. And 7, we will launch EC2. Then 8, using a user data or user script. Install Apache. One more thing on GC2 and security loop. Okay. And expose sample application. Got it. These are the things today we will do with the Terraform. So I will break down each services script. Okay, I mean the YAML file. So I will explain each one. Now I have my machine. This is my local machine. Okay. My local machine. I have created one directory called Terraform. Terraform. Nothing there. Okay. So when we I already installed AWS CLI and Terraform in here. Terraform. The 1.6.1 version here. So when we type the Terraform init command, okay, Terraform, ensure that all our Terraform files are in the same directory. Otherwise, we will get some error like this, okay. Terraform installation installs in an empty directory. The directory has no Terraform configuration file. Got it. So we ensure that all our configuration files in the same directory before executing the Terraform script. You may be working with the Terraform immediately to create a Terraform configuration file. So I am asking you guys, what are things we need to first create here to connect with our machine? I mean the service AWS. That's all. Anyone? As of now, I configure my. I mean, I have my local machine. This is my machine, and I installed both AWS CLI and Terraform. Now I am going to configure and create a connection with the AWS console. Just configure. Yeah, it's already connected. Okay, so that's why it's here. You see, this is my access key ID, and this is my sorry. This is access and this is secret key. This is secret and this is access. And I already mentioned US is to one. That's why it's again show here. Called region. Yeah, that's fine. I already configured that thing. I mean, there's a connection between this machine to AWS console, AWS account here. So now I need to mention my provider, right? All of you. So that I'm creating a file, okay? File name provider.tf. This is my provider. Okay, my provider AWS. Now it's done. Now I am going to init again. Terraform init. See, initializing the backend, initializing provider plugin. Now it's connecting with the plugin, okay? So we will get the output Terraform as successfully initiated with our AWS plugin, right? So that success. So now we need to add our resources. What are things we are going to cover? Okay, I mean deploying. So in our case, these are the things. So this is for VPC. Okay, got it. So VPC, first we need to mention our resources. Okay, resources, then the resources type, then the name. Got it. Here our resource type is AWS VPC. Then the resource name demo VPC. Got it. Then under that VPC, we need to provide the IP, right? The same thing. How we manually configure a VPC. Okay. First we go to the VPC. See, in my case, there is two VPC. Okay. One is my default VPC and one is for use core. Okay. So how we manually configure VPC? See, first we come this page. Okay. Then we need to provide a name for the VPC. That is name tag. Okay. In my case, the name tag is production VPC. Got it. So first we need the name tag here. Then we need to provide the IP, right, for the VPC. Then we create the VPC, right? The same way we need to provide each thing as a code, okay? That is here. The resources, AWS resources, then that's VPC and demo VPC is a type and sorry name. Then we are provide the tag name that is production VPC. And here I'm providing the IP 10.0.0.16. Got it. So when I'm executing this code, it will create a VPC. Okay. Here we can see a VPC. So the next thing we need to configure is internet gateway. So this is the code for creating internet gateway. Okay. Again, internet gateway is another resource. Okay. So we need to provide the type and name. So resources, the type is equal to AWS internet gateway and the name is gateway. Okay. Here we can provide any name. Okay. So after that, we need to provide the VPC ID. Okay. In our case, otherwise, how this communicated? I mean, for example, first we created VPC, then go to the inter gateway, and we need to attach that gateway to the VPC, right? So this is here, this is attaching, okay? I mean, we need to refer the VPC ID here. So the VPC ID is equal to our VPC. Our VPC name is AWS VPC dot demo VPC. See, AWS VPC, the type, then how we expose that thing in here is the name and the name, I mean type and the name. Both are we divided by a dot, okay? The same thing. Resource. AWS resource, we mentioned the VPC ID. After, we need to provide the dot ID. So it will know that's the ID of the VPC. Got it? This where we refer this VPC, our VPC in different stages, okay? For example, creating another thing, subnet or root table. Each scenario, we need to provide our VPC as a reference, so that the source know that is under the same VPC. Any doubt? Anyone? Okay. Then the next thing is, I mean, gateway is done. Subnet. Same way, we need to provide the sources. Here the resource type is AWS subnet, and the name is my subnet. And we need to provide the VPC ID here as well, because the subnet is under that VPC. Same way, we need to provide the same ID, the type of the VPC and the name of the VPC. Okay. So we need to provide the IP for this subnet. So 10.0.1.0.24. This is my subnet IP. And we need to provide the availability zone. Okay. I am choosing AWS, I mean US East to 1. So there is so many availability zone in US East to 1. I am choosing 1A. And the name, tag name. That's called the subnet. Tag name is called production subnet. Got it.
Please, can you show me back the internet gateway?
Yeah, this is our gateway.
Do you have the files like every file separate from the other, or are you gonna combine all together in a one single file?
Yes. I am just I mean segregate each thing. After that, we will integrate all the files as a single file called main.tf. Then we will export. Got it.
Yeah, okay.
So now we are cover AWS. Yeah. Subnet is done. Now the next thing is a route table. Okay. After creating subnet, we need to create the route table for routing. So this is our route table. Here we need to provide the name of our sources. Again, we provide the type, the name, and mention the VPC. So this is our VPC ID. Then yeah, CADR block. This is root. Okay, under root. Each block. Okay, these are blocks. Okay, this is block 1. This is block 2. This is another block. VPC ID is a block. Okay. So in the next, we create another block for routing purpose. So here we need to provide the root. Okay. So the CLDR for root is 0000/0 for the exposing our application public, right? I mean, this way we make our subnet as public, right? Same thing. When we creating root table, we go to the root and add one more. That is called here. Okay.
I have a question. If we have multiple routes, how are we going to show here?
Same way, when create another block, another route, same, it's copy, again paste here. You mean for one more route we need to create, right? For NAT gateway, right? So copy the thing and paste down. Then the destination and the target we need to change as per our need. Here our destination is C and the target is internet gateway. This is the ID of the internet gateway. Okay. So the same ID, I mean, this is the ID, internet gateway ID. ID is AWS internet gateway dot GW. That's our ID. Dot GW dot ID. This way we refer each resources together. Got it? Yeah. Now internet gateway. Now we need to add route. Oh, we already added the route. Okay. This is the routing. Then yeah, subnet association. This subnet association, the resource type is AWS root table association. The name is root table association. And subnet ID, we need to provide a subnet ID. So subnet ID is AWS dot my subnet dot ID. Go to subnet, I will show you. So here the resource is AWS subnet dot my subnet. The resource is our ID here, right? So we need to provide the subnet ID. Then we need to provide the root table ID as well to associate. Okay. So this is our resource, root table resource, AWS root table dot ID. This is the resource of our root table. See, this thing we add it as ID in association, and all scenario we mention the ID as a resource. Okay, the resource. So done. It's done. Now we need to provide the code for launching EC2 mission. See, this is for deploying machine. So this is the sources AWS instance and the name is web server. Okay. Now Route 53, we are not going to using any URL here. Okay, we only use IPs. And yeah, then AMI, we need to provide the AMI of the machine, I mean the image. So this image for Ubuntu machine. Now instance type, I'm going with the T2 micro. Key name, we need to provide the key name. Okay. In my case, key name is no. And availability zone, use is to 1 that's fine. And the name of the machine. That's called a web server instance. Now, this is my user data, okay? This is a script. When the machine launch, it will execute, okay? So we can provide any user script here. So this is this script for after running machine, it will execute, okay? First thing is sudo apt yum update the machine. We didn't manually do the things, okay? The script will do all the things. Then the second thing is install Apache 2. Got it. Then the stage, third one, start the Apache. After that, we write something to expose, that is sudo bash echo. This command for exposing something what welcome to Guru School. This will expose and save to this directory. Var www.html. The same, I mean, the application directory where we copy the application code. After that, after executing this all code, we will get the output. Okay. Output is public IP, and the public IP will getting from the value AWS instead of web server. This machine public IP we will get, okay, as an output in Terraform. So just to copy the IP and accessing our application. For that scenario, I will add that output there.
Then I have a question. Here, key name is there now. Are you creating new key or using the existing missions
The
key?
existing.
Okay. Sure. Thank you.
Yeah. Any other doubt?
So the AMI which you have used is Ubuntu server?
Yes, this is Ubuntu. Last 19, okay, I will show you.
Okay, in the case if it is Ubuntu, we need to put the Ubuntu commands in the bootstrap.
Yes.
Otherwise, we need to provide Linux bootstrap, right?
Yes, here you see our command for user data command. Yeah, apt. If you are using Linux, then here the yum we need to provide yum.
Okay, sure, thank you.
So some more thing we need to add for creating the web server, because as of now for this resource, I mean the instance creation resource, we didn't provide any security group or subnet where this machine goes to, I mean, deploy. So we need to provide subnet ID and security ID as well for this machine. And one more thing, we need to provide the public IP. For example, in this case, we didn't mention public IP. Okay. Otherwise, when deploying this machine doesn't have the public IP. That's thing we need to add here. I already added in the main.tf. Okay. So these are the step-by-step explanation of each resources. So I am combines all the codes as a single file. This is my single file. Okay. So same thing. So this is for the VPC. This is for internet gateway. This is for root table, and this is a root. This is for subnet, association, security group. Oh, we didn't cover the security group, right? So this is our security group. Okay. So in this case, I didn't go with the default security group. I created one security group. Okay. That name is type is AWS security group, and the name is instance SG. And the name for the security group is web server SG. Description allow all HTTP. This is for knowing the thing. I mean, what are the thing we expose in here. So I'm just exposing SSL and HTTP. So I am providing the VPC ID same way, the resource of the VPC. Then ingress. Ingress means incoming inbound traffics. Okay. From 22 exposing as TCP from anywhere. So anyone can accessing this machine, okay, via SSH. Again, I am adding one more security rule here, okay. Adding one more inbound rule, that is for 80 TCP as protocol as TCP, and same way anyone can access application we are exposing 80 for the application. Okay, so anyone can access the application through 80 port 80. And one more port added for HTTPS TCP. Okay, it's port 01. Yeah, we didn't need these two, but I'm here added that thing. And the tag for the security group is web traffic. The same way I'm included that thing here, security group. Then mention the AWS web server code. Here you can see I'm adding the VPC security group ID here.
I have one question in the security groups.
Yeah.
Right? We used only, we put the default TCP name. Why not we mention HTTPS or HTTP? In the line number 45, instead of SSH, you mentioned TCP. Line number 51, you used TCP instead of HTTP. And line number 57 also, instead of HTTP, you kept TCP. Same at line number 63. It is HTTPS.
No. The protocol is TCP. I will show you. I mean, coming to networking, all things are run as TCP. Okay, the main protocol is our TCP. TCP and UDP, there is two things, right? I think we cover the TCP and UDP.
Understood. Thank you. I think now I understand.
Okay. See, TCP. Here we can provide the port number. Okay, like that. Again, we can provide the 443. Got it.
But why? What I am asking is,
or else we can choose the default service like SSP.
yeah,
So it will
that
automatically
is
affect
what
that
my
thing.
question.
Yeah.
Correct. Correct.
Two-way we can mention, no. But all are going with the TCP, okay. Now coming to web server, yeah. We need to provide the ID and the machine type T2 micro, machine keys no, availability zone is just one. Now I added one more thing called associate public IP address is equal to true. This command we need to mention, otherwise our machine is the IP, public IP is disabled. Got it. Here, public IP is true, so we will get the public IP whenever we deploy this machine. Same way, we need to provide the security group ID. In our case, our security group ID is AWS security group.insert.st. That's right? The resource name here, AWS security group instance st. So same way, we need to mention that security group in web server. Sorry, the launching machine. And same way, we need to add corresponding subnet ID. In our case, our subnet ID is AWS subnet.mysubnet.id. See, this resource thing we mentioned as the ID in our machine code. So I think all are done. The user data. Yeah.
Hello.
Yes.
Yeah. Can you show me the place where there is the configuration? I mean, connection of the subnet and like VPC. How the connection?
How coordinates?
How did you connect them? What's the place where we can see the connection in this file? Like, how did you connect the subnet to the EC2 or to the VPC. I want to see that one.
Yeah, that's why we are adding the IDs. See, first we configure,
Okay.
first we deploying a VPC, okay? The resource type is AWS VPC. See, this is a type and this is a name. Okay. The type and name we mentioned as the ID. Got it? So next I'm creating AWS Internet Gateway. So whenever we create a Internet Gateway, we need to attach that Internet Gateway to the VPC, right? So here my
Yes.
VPC ID. So I am creating one more thing called this is one more block, okay? That's called a VPC ID. So here we need to mention the corresponding VPC ID. So the ID is the resource type and name. How we rewrite thing like AWS VPC dot demo and underscore VPC dot ID. Got it. This thing I mentioned again here, and in when I create a subnet, I again mention that here, and security group again mentioned here. See, yeah, that's where I mentioned the VPC ID. So this ID as a reference, okay? So it will interconnect with the corresponding VPC. Same way we again I have mentioned the Internet Gateway ID here for root table. See, got it.
Okay, I see.
Any confusion?
Subnet, AWS route table, that route table ID. Okay.
Whenever we provide the ID is the resource type and name, okay? And we provide as
Okay.
as a dot like that, okay? That is AWS VPC. That this is the type of this is the type of our VPC. See, the type of our VPC is AWS VPC. Then there's a dot. We need to provide a dot when we provide the information as a ID. So next is the name, VPC demo. See, our resource VPC name is VPC demo. Then dot ID. So this is our root table ID. Same way. Got
Okay.
it?
Yeah, thank you.
Yeah.
Sir, if we have any IAM role for our instance, we need to mention it in the instance block.
Yes.
Okay.
Inside this block we need to mention.
Okay, thank you.
Because
So,
we are attaching that role inside the machine, right?
Yeah.
I have one more question. When this run, it will generate a. We have to choose a name for this PIM key or a type of authentication token, right? So when it creates, where does it save?
Where this, I mean, you mean the state file, or?
So let's say I choose like my new production PIM key, let's say, because when I create these instances, I need access, right? So in the script, I will specify create a PIM key and with the name, with so and so name. But now once the ECs are created, where is the PIM key being copied so that we can log in?
That's all in the state file. Yesterday I will explain the state.
Oh,
Yeah, you remember that.
okay. Okay.
Whenever we are running this Terraform code, we will get a Terraform state file. Okay, the current state, all the details of the current state. I mean the state of our infrastructure. Got it? So I am copying the entire code, copy, then coming here, create a new file, main.tf, because all our main files are in this file. Okay, copy, save and exit. Fine. ls. Now I have that two file. One is my provide.tf and main.tf. I am in Terraform plan. See, in our plan, there is 7 thing added. Okay. So I'm good to go with the apply command. Terraform.
One more quick question.
Yeah.
So we have all the necessary ingredients to create a EC, but if we want to create 3 or 4 ECs, where are we specifying the count, all those things?
You mean creating at a time, creating more than 2
One
or
EC.
3
Yeah.
machine, virtual machine, right?
Yeah. Yes.
Mm, see,
I mean, if you want, you can explain at the end also. I don't want to stop your flow.
no problem. I just explain. I mean, you see, our bits on. See here, count is equal to count
Ah, okay.
is equal to 2 or 3 or 5 like that. So we got 2 missions, same mission here when we executing 2 mission. Got it?
Okay.
Yeah. Here I am going to apply. Yes. So it's creating, okay. I think everything is good. Then it's create all the things. Creating step by step up. Okay, what are things we need to mention in the board? So it's still creating. Now creating the web server. It's already created the VPC, security queue, subnet.
Assuming, sir.
See, everything is done. Apply complete source 7 added. I'm just copy the public IP and verify the application if there or not. Give some mails some time because now the user data, yeah, now the Apache instance, see, script is running background. See, now it's done. Now you got the power of the Terraform, right? So we go manually to see the things. So first to go to the VPC. There is only 2 VPC, right? One is for the default and one is for the guru school. Now there is one more VPC called product VPC. And same way in there is one subnet, one boot table there, one inner gateway there, then security group there, machine one more added in our. See, this is our No VPC. VPC production VPC. Got it. And coming subnet. Prod subnet. Root table. Prod root table. Then gateway. Prod VPC. This is a gateway.
Quick question, please.
Hmm.
Like at work, and they want you to do all this, how much time they can give to you so you can configure all those steps in order to get to the result?
You mean the
How
time
much
tag?
time? Yeah, how much time they can give to you to do all these, write the file and
One of the one of the main benefit why we are using Terraform, because this is the infrastructure we have. Okay, I mean this infrastructure. So similar infrastructure we need to uh, you know configure. We are just copying the enter command and customize it. For example, we need to add one more subnet here. So here we can copy paste and rename the subnet and all the things. So one of the main thing is we can use the same code and use it again. Okay. So from scratching, I mean, as a newbie, we need to sort it out all the things and arrange the things. So it will take some time. So this is our machine, okay, the web server. See the key pair is new. Yeah. Everything is done. Let's can see the state file. See terraform.tf file. Add terraform. .tf state. This is our state file.
So somewhere I see.
Yeah.
So somewhere you mentioned a key name, right? But is that key you generated separately, or is this key you generated using the Terraform scripts itself?
Yeah, it's script itself.
And how does it know it's saved in your downloads? Where did we mention that?
No. That's in the state file actually. So in our case, we provide the existing key. Got it.
Oh, you used existing key right now.
Yeah. This is my existing key for new. New is my existing key. See, this is the existing key. So I am providing this key. Got it.
So yeah, maybe at the end of class, would you be able to show how to generate a key also with Terraform?
Yeah, no problem. Okay. So now we are deploying all the things, right? As using Terraform. So now there is so many resources, services, VPC, subnet, router, internet gateway, machine, all things, security group, all things we created through the code. Okay. So manually, how we delete these things? Just go to each Windows and delete the things, right? So using Terraform, see how we destroy the entire thing with a single command. Terraform destroy. Okay, when I am hitting enter, the entire thing will delete. Got it? Yeah, Andrew. If you Andrew approve, then we didn't mention the yes again.
Can I ask you a question?
Yeah.
Can I ask you a question?
Yes, ask.
Hello.
Yeah. Proceed.
Are you using only your on-premise, like a VS Code to create, or you are using another server to create all the resources?
All the resources?
Yeah, before creating the resources, you are using your local CLI, like it's not connected to a server, like VS Code, standalone VS
Yeah,
Code.
I'm not authenticated with the VS Code. Okay, my VS Code is not authenticated with the AWS account. That's why I'm
Yeah, but
using.
I'm seeing another server that you are using to
Yep. Your voice is breaking
do the
actually.
destroy.
Yeah. Again, once again.
I'm saying I see you are using a server to execute the destroy over here. And I'm getting confused because I thought everything would be done on the local. And even if you want to use the destroy, it will be on the local.
Anyone got the question? Yeah. Can you ask the question as a text in our chat?
Can you hear me now?
Yeah.
I'm saying that I thought when you use your VS Code only to create your resources, you use the same VS Code to execute your destroy. But I'm seeing that you are using a server, Terraform server, that is EC2 running right now.
Yes.
Yeah.
This is my consider this machine as a local machine, okay? Because I didn't configure AWS CLI and Terraform in my local machine. Got it? My machine is a Windows machine. So the same purpose.
It's okay.
Yeah.
No, I got it. Sorry.
Okay.
I got it now.
Yeah. So that I am using a machine from cloud and do the same thing.
Yes, I got it now. Sorry.
Yeah. And I have all the files, you see. Main.tf, Terraform, all the things. If you are running with this Visual Studio Code and authenticate with AWS CLI, the same way we can collect the data from, the code from this Visual Studio Code. Anyone have any doubt?
Yeah, please can you in the file explain me a little bit about the ingress?
Ingress is nothing. That I will show you. Go to the security group. Ingress means ingress traffic. Incoming traffic. Okay. So before, when we deploying application in here, we are going to see in this mission. This mission have only one inbound traffic rule. Okay. The ingress. So, for example, security, yeah. Here the ingress is 22, right? Open port 22 for all. Anyone can access through my machine to my machine through
SSH.
port number 22. So the same thing I am mentioned there, okay? Like TCP, custom TCP, and 2020. The same thing. And the next thing is 80. Add one more row. One more ingress tag there. 80. And everyone. The same thing mentioned here. And again, 443, same way. And TCP 443 and access anywhere. Anyone can access the machine or the application through this port.
Okay. It is okay. Thank you.
And one more thing I am adding here, egress. See, what is egress? Egress is outbound traffic. For my case, outbound traffic is all. I am enabling all. Any other doubt?
It's okay.
Yes. Okay, fine. Then this is the way we automate the entire infrastructure. Okay. So as per our need, we need to customize our code for each services. Fine. And one more topic there I miss. That is one of the main topic. Anyone know deployment strategies in Kubernetes? Anyone?
That is blue-green deployment, right?
Yes.
Okay.
Not blue green. There is so many deployment strategies, including blue green.
Yeah.
Yeah.
Rolling update
Yes.
and
Deploy.
canary. Yeah.
Strategies. Okay, there are different types of deployment strategies. Okay, as a DevOps engineer, we are the one who brought up all the things and deploy the application. Okay. As per our requirement, we need to choose this which deployment is suitable for our application. So there is some common when they ask to use Terraform manage. How do you go by that? Yeah, for that we can go through the key of state file to see all the infrastructure and uh, there is the Terraform files there. Just to go through the files and we can identify this is the existing infrastructure and all things included. I mean services included in the Terraform file and yeah. So coming to strategies, there are some common strategies there. Okay, whenever we are going to deploy application. So the common deployment strategies are blue-green deployment, canary deployment, rollout deployment, A/B testing. So many deployment strategies there. So yeah, roll and roll out. Repeat. This is one of the strategy. Okay, deployment strategies. Okay. So one is this. The next one is rolling update. These are the questions we are facing, okay, when we are, attending DevOps call. So one is shadow, canary. You heard about canary, right? Canary is one of the type of strategy, deployment strategies. Then to be six AB testing. Yeah, these are the things. I mean, different types of deployment strategies, and each strategies have their own unique working principle. Okay, like when we are as per the requirement, okay, project requirement or application requirement, we need to choose the corresponding strategy. Good. For example, yeah, if you are choosing a recreate mode strategy, okay, the first one, this is the recreate mode, okay. So when we, choosing this strategy, for example, yeah, we have two application version. One is V1 and one is V2. Okay. So this is a great. Okay. So all the existing instances are terminated at once. I mean, for V1. Okay. Then and new instances with the updated versions are created. So here what happened, the version 1 instances, for example, this is application version 1 and some instances. For example, this is in some pod, okay, in Kubernetes. So when we are using recreate model, all the instances is deleted, then recreate and recreate the same pod, contain all things, and the application is updated to version 2. Here the problem is downtime, because this will destroy, right? So the users can't access the application at that time. So the downtime is here. Downtime, yes. For this strategy, we are facing some downtime. Got it? So I'm going to the next scenario, like rolling update. Same thing. All strategies we are using for deployment application. Okay. So there is the version 1 and version 2 there. Again, V1 and V2. So we are going with the rolling the application instance. Okay, here see the application instance are updated one by one, ensuring high availability during the process. In this case, we didn't face any downtime because it will, rolling, I mean, sending the application, newly application to the next instance. How I will draw the thing, like using a, yeah. For example, here there is a load balancer here, right? Load balancer. Load balancer will send the traffic to this version 1 and version 2 is in a pod, okay? Remember that. This is pod, and here there is a pod. These are different pods, okay? This is pod 2 and this is pod 1. So here you see the version 2 is here and the version 1 is here. So what happened here is application instances are updated one by one, okay? So here there is no downtime. Downtime, no. Because the load balancer will route the traffic to the corresponding instance and it will never bother about the application is updated or not. So our application is up and running all the time. And this strategy we are using for the periodic release, okay? Like it's for example, monthly or 2-month period, we need to add more feature to the existing application. So we are going with this strategy. And coming to shadow, that is it's a like of we copy of the live traffic, okay, and redirect to the new version for testing without affecting production user. That is, we create some application as a shadow and just follow the traffic. Like, for example, there is one application here, okay, and this is our shadow application. This shadow application is version 2, okay, but we are more concentrate on the first one, I mean the existing one. This is version 1 main application, and this is version 2, but this is called this application we to consider as a shadow, and we copy a live traffic, okay, and redirect to the new version for testing without affecting the production users. This is the production users, okay, and this is a shadow machine, and we checking this version 2 as a shadow and routing some traffic to the shadow machines. And this scenario, we are mostly some complex deployment strategies. We are using some complex deployment strategies and involves, mock services or interacting with the new version of the deployment. So that scenario, we can use shadow. And the most popular deployment one is Canary and Blue. Okay. So most probably we are going with the Canary or Blue deployments, Blue-green deployments. So coming to Canary, it's a like the new version is released, okay, to a subset of users or servers for testing before the deployment. For example, we have an application called V1, okay, so there is 100 users are accessing, okay, consider our application, but we have a V2 version, newly version there, but we didn't expose to production before testing. So we take some traffic from this. This is our traffic, like 100 users are accessing our application, consider. So we divert some users. That's called subset of users. Subset of users, like a 25% of users are we routing to the version. Got it? And 70% going to the version 1 and 25% or 30% we are going to version 2. So in this case, downtime, no downtime here. We gradually moving the traffic, okay? As real scenario, we gradually moving the traffic to enter traffic to V2. And finally, we decommissioning the version 1. For example, first week we moving 30% to this, and then it's 50% again after some time, then 70, then 100. So we can see if there is no issue or anything there, we move 100% traffic to the V2 and decommission the V1 application. Got it. So we are using some networking thing here for using Canary, like Istio. One of the most thing is Istio. Istio is a service, open source service to secure our Kubernetes cluster. Okay, so that's one of the main thing. Istio, how we secure application entire Kubernetes cluster using Istio. And Istio is nothing. For example, this is our Kubernetes. Using Istio, we can divert the traffic. Okay, the YAML when we deploy the Istio in our Kubernetes cluster, then there is a YAML configuration there. So in there we can type the traffic. Those this much traffic go to this pod and this much traffic goes to that pod, like that. And coming to Istio, there is a thing like how we secure our application. For example, this is the pod and this is the pod, another pod, okay. So pod to pod communication there, right? And there is a container inside the pod. So as a user, this is again a remote user. So the user access the application directly, okay, directly our container, right? So this is not a proper way. I mean, this is not secure because the user can directly access our application. I mean, the container. This is I mean, this connection through some API, okay, but this is not good way. So that when we creating Istio or establishing Istio in our Kubernetes cluster, there is a envoy something. I mean, sidecar, okay. This is called a sidecar container. Sidecar container is nothing. First hitting the traffic to the sidecar, okay, not direct hitting your application. So this is another way of secure, okay. So the sidecar here to the application, and then there is a connection like API. So the sidecar will getting the application, all the things to the user. Got it. If anything happen, we can recreate the sidecar, and that doesn't affect our application. This is a simple scenario. There is a lot of things we can using with Istio. Most probably, we are using Istio for securing our Kubernetes cluster. So coming to blue-green deployment. Blue-green deployment, you know, there is same thing. We have two application consider, app 1 and app 2. And here the V1 is blue, okay. This is our blue. And the V2 is green. Okay. And there is a load balancer. This is our load balancer. Load balancer will route the traffic, right, to the corresponding application. So coming to blue green is green is 0%. Considers the traffic goes to the blue is green is 0% and green is 100%. Okay. So here the two identical environment are maintained. Okay, one with the current version blue. This is the existing version. This is the existing version. I mean current version. That is blue, and the other with the updated version. This is our updated version, green. Updated version green. Traffic start. Okay, in this scenario, traffic start with the blue. I mean, if anyone access our application, that's go to the blue. Sorry, yeah, blue. Then switch to the prepared green environment for updated version. Got it. Here the downtime is no. Downtime is no. And scenario like I mean, some big size application, we didn't face any downtime. Okay, for example, some high stake update or anything like that, we are going with the blue green deployment. So whenever we choosing the strategy, the requirement there, okay, so from the lead or the manager, these are the requirement, or this is the canary is our requirement, or blue green is our requirement. So as per the requirement, we need to perform the task. Got it? Anyone have any doubt? So concentrate on blue, green, and canary. Okay, these tools are most use case one. We are going to canary most scenario. Anyone have any doubt?
Can you explain A/B testing again?
Okay, B testing. Wait, I will explain. Coming to A/B testing. There is two versions of application. Okay, so when there is a scenario like for test case, okay, user optimizing user experience. So okay, there's a use case. So we have multiple versions of application, and these versions are concurrently tested, okay, on different users to compare performance of user experience. So that purpose, I mean that use case, we are using A/B testing. Like, for example, load balancer here. This is a load balancer. This is version 1 and this is version 2. Source, here user, here another user, and hitting the load balancer. This is another user, okay. This use case for user experience. Hitting the load balancer and load balancer routing the traffic to version 1 and version 2. Here there is no, I mean, downtime is not applicable for this scenario. So in this case, multiple versions perform with the concurrently testing, okay, on different users. Different users in the sense of like some users are using laptop, some users are using mobile, like that, okay. For experiencing, I mean, optimizing user experience is one of the use case for A/B testing. This A/B means in the sense of like This is considered as APA, okay? That is a laptop. And here again, this is B. This is for a mobile device, like that. Got it? Any other doubt? If I got a chance, then I will show some real-time lab for deployment, okay? That is called for example, you can try canary or A/B test. So you will get more idea how the traffic car goes and how we changing the existing environment and moving to the new environment, like that.
Yeah, a practical example would help us more.
Yeah, then I will set up a lab for that, okay? Got it.
Yeah, especially while, and I mean, it is little bit abstract, understanding the difference between canary and A/B testing. That's why I asked the question.
A/B testing for example, that is for user device experience or user experience, okay? Optimizing the user experience. For example, the application is optimizing for a desktop view or desktop applications. Then some other scenario like mobile, accessing the application through mobile. So that's all under the optimization purpose, okay? A/B testing. Canary is different strategy. Like we need to traffic. We have one application called V1, and we divert some subset of users, okay, like a 25% or 25% to there is a new version there, okay, V2. So we routing a subset of users to the version 2 for accessing the application, and that is a test purpose, okay. So after some time we conclude that the version 2 is good, and uh, we are adding more traffic to that version 2. Gradually, all traffic goes to the V2, and finally we decommission or delete the V1. Got it?
Okay.
And yeah. So coming to lab, you will get more idea. Okay. Anyone have any doubt? Then we can wind up, right? So coming section, I will show you a deployment strategy. With a single strategy, you will get idea. So the other strategy is the same, similar way we are going. But the strategy may change, but the process is similar thing for each one. The thing is how we transitioning, okay, to the existing one to the newly version. There is different transition methods like these strategies. As per our need, we choose the corresponding one. For example, some strategies have some downtime, some have no downtime. So as per our need, we need to go with the corresponding strategies. Got it? Then we can wind up, right? All of you.
Yes, sir.
Yeah.
Okay.
Okay. Okay. Then okay. Bye. Bye all.